Hare Krishna, everyone.
Hare Krishna. Sorry for the delay. I was just putting my son to sleep.
Yeah,
So
no worries,
quickly,
Prabhu. Yeah, it's already quite late for you.
yeah.
So,
So yeah, had a very busy day. So let's get started. Thanks for waiting. Okay, so last time we covered retrieval augmented generation. Uh, this time we'll be looking at the other technique, which is related to fine tuning. But before we go there, I just wanted to quickly understand, like, how many of you got the time to go through the paper that I had shared? Like, you can just put yes in the chat box. Okay, so I'm assuming no one got the time. So, I would highly recommend looking at the papers because that essentially forms the context. You may not understand everything from the paper. You may understand, say, only 5% of it, but that would basically provide you the required context to uh, sort of, yeah, understand the things better in the actual class. Okay. So, as I said that last time we looked at retrieval augmented generation, this time we are going to look at fine tuning. So, retrieval augmented generation is something that would let's just recapitulate that once. What is retrieval augmented generation? Then we'll come to fine tuning. Okay. So in retrieval augmented generation, last time I covered that what we do is we have a vector database which stores all the information related to the text corpus or document corpus that we are interested in terms of querying the information. All the text information gets converted into into vector format, and those vectors are stored in a vector database. Okay. And once we really ask a question, okay, or a query, it goes and looks for query is also converted into a vector, and then it tries to match, okay, which vector out of all the vectors in the vector database, which are those vectors which match the query vector most. Basis that it retrieves some information or vectors from the vector database, and those actually become those retrieved relevant documents become part of the prompt, okay, which is fed to the model. And then the query also goes along with this, along with all this context, and then the answer is generated. Now, this is a step play, like this is a process, okay, where we are not touching the model at all. All what we are doing is we are in the along with the prompt, we are passing additional information relevant to the query. And where is this information coming from? From the vector database. Now, when we think about fine tuning, the main difference is here we do change the model itself. So the model itself gets updated. And when we say it gets updated, it actually learns, okay, it memorizes the information say related to the document corpus. So in case of RAG, we are storing that document corpus in the form of vectors in a vector database. But in case of fine tuning, what we do is we make the model, we make the LLM learn all those things. Okay. So that's why it is called known as fine tuning because there is an existing model, and what we are doing is we are sort of tuning it, okay, further. Okay. So That was like sort of recapitulation of RAG.
Prabhuji, I have a question. I'm sorry, I not understand one thing
Mm-hmm.
because I now when you talked about so, right now and what is in the paper. So in your paper, it was saying that we retrieve answers in the in some like we create a keyword framework search. Is
Yeah, yeah.
keyword framework search is same as your vector store or whatever you are saying? Is both are same?
No, good that you read the paper. Uh, so in that paper, what we are telling, what we have done is we are showing that even with RAG, okay, there are some limitations. Okay, let me open the paper. And yeah, like uh, Puja Mata brings a very good point, okay, about like how are the things in that paper different, okay.
Yeah, Prabhu, because that was
So,
very well thought written paper, and I was like, I hardly understand AI, but at least it was understandable to me little bit.
okay, great. So let me open that paper. This is the paper. And this is the overall workflow of the keyword augmented retrieval. So here what we are doing is instead of really matching, okay, which vectors are matching the query vector, what we are doing here is uh, we are looking at comparing the keywords in the query and keywords in the information which is stored. Okay, so instead of creating vectors, what we are doing is in the text corpus, from the text corpus, we are extracting keywords. And similarly, from the query also, we are extracting keywords. Okay, those keywords are actually highlighted here in blue, light blue boxes. So this is suppose your input, okay, document. And all the keywords in this input document, you can see they are like marked by these light blue boxes. And this is your query. All the important keywords in this query are also marked here. Now what we will do is we will try to match the keywords, okay. And whichever, say this paragraph, okay, like if the keywords in this paragraph match the keywords in this in the query, we will say that there is a match, okay, and this paragraph is now important as a context to be passed along with the prompt. So instead of matching, comparing vectors of query and vectors of the text corpus or the document corpus, we are looking at keywords in the query and keywords in the document corpus. And basis that we are identifying which paragraph or which lines will really go as context along with the prompt. And this technique actually does very well, okay, in case when the information is actually very sparse. Okay, so by sparse, I would say that say that word is appearing just once, okay, in the entire chapter. Okay, or maybe just twice it is appearing in the entire chapter. So like so those type of data sets are known as sparse data sets, where the information is very sparse. And on those sparse data sets, what we found is RAG, okay, retrieval augmented generation was not able to really get any answers, okay, because it was picking the wrong context by looking at similarity between query vector and document vector. Whereas keyword augmented retrieval did a very good job because it was able to identify the relevant context. So that's what we have summarized here in this table. Okay. So That this was like the main idea in this paper. So does this answer your query?
Yes, Prabhuji, very clear. Thank you.
Yeah. So this is a sort of keyword augmented retrieval is sort of a alternative to retrieval augmented generation. Okay. And this would work, okay, when the information is sparse. Okay. I'll give one more example of sparse information. For example, name of a person. A name of a person may appear just once, okay, or maybe like twice or thrice, okay, in a chapter. And most of the times we may be using pronouns for that person. Now, if you are saying, okay, like, okay, tell me about, say, Narendra Modi, okay. Now, if the word Narendra Modi appeared only once, okay, whereas in the rest of the paragraphs it is appearing as Modi, 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 okay, a Prime Minister of India, then vector-based similarity won't work, right? Because you are saying, okay, what did Narendra Modi do? And the word Narendra Modi is appearing only once. And suppose your vector similarity does not give a good match, okay, then you are going to lose information, right? So in such cases, we have seen, okay, like particularly name or places, uh, things which are actually referred using pronouns, if they are appearing in a sparse way, then RAG fails. RAG has its limitation, but keyword augmented retrieval does a very good job there. Okay. So coming back to the slides again.
Yeah, Prabhu, it's very nice paper. Thank you so much.
Okay, thank you, Mataji. So let's come back to the fine tuning part. And this fine tuning actually today going to cover using a case study. Again, this case, like I think the demo for this sort of done in the previous class. If you have not gone through it, means you can look at this website, or I can also put the YouTube of video of this.
Welcome to Vidyara, your smart
I'll
campaign
put it in the chat here.
developed by
Okay. So in like this actually Vidyarang actually uses a mix of RAG and fine tuning. Okay. So RAG, because uh, you may be having like, suppose, so the overall purpose of this platform is to onboard different type of courses or make courses out of books and then convert them into a conversational interface where you can chat with that study material. Now that study material is something which may keep changing, right? Like suppose a new book gets published, okay, or suppose you get hands on some notes, okay, taken by someone else, and you want to create a study material around it, so that you can chat with it. Like those type of things are subject to change or evolve with time. So it's not really feasible, okay, that you go and fine tune the LLM every time, because fine tuning is time consuming and expensive. You'll see all those arguments, okay, in a more detailed way. So to feed the information, any new information, RAG is something which does a good job. So that's where RAG is being used. But things like personalization, the way it responds, okay, the way it answers, those are things, okay, where fine tuning does a much better job, because the way it should respond, okay, won't really change a lot, right? Means you can really you can, for example, you can select, okay, that yeah, it should talk like a professor, okay, or it should talk like a primary school teacher, or it should talk like a doctor, okay. So those things won't really change, like those type of personas, the personalities of teacher, those are going to remain like that. They are not going to change much, but knowledge is something which will keep evolving. So that's why like Vidyarang uses uh, fine tuning for personalization, whereas it uses RAG for uh, feeding the latest information. So I'll skip this. Okay, I think I covered this. Okay, that any document is uploaded. Once it is uploaded, it is converted into vectors. Then it is stored into a vector database. Okay. This platform also supports, like, you can paste YouTube links where the transcript is available, and it will take the text out of it and then store it in the vector database. And it supports multiple file formats: PDF, Excel, CSV, TXT, Doc. Okay. So the first part is, okay, like suppose you so like in this, I think they uploaded this book, How to Learn Faster by Julian Lin. So you upload it, okay, and then then you ask the question, okay, it is able to respond. Okay. And this is the prompt, okay, that you are an AI assistant to help students learn their course material via conversations. The following is a friendly conversation. Okay. And then here is where the relevant context is coming from the vector database. And then you have given an instruction that you provide a detailed answer with logical formation of paragraph in the same language as the user. Okay. If the user is asking question in Hindi, then the answer should also be in Hindi. If the user is asking question in Telugu, then the answer should also be in Telugu. Okay. So now this part is something where RAG is being used. Okay. But when we really need some personalized interaction, okay. For example, there may be a favorite teacher of yours. Okay, and like that teacher may be very popular, okay, among a lot of people. And that teacher or professor may have a particular style of teaching, right? Probably they may be provoking or in like sort of uh, like motivating people to ask a lot of questions. Okay, maybe that is their style, or maybe they are very detailed. Okay, detail oriented, and they go into the depths of things. Okay, uh, so these are all personalities. Okay, or persona types. So that is the part where fine tuning is actually happening, working, whereas the knowledge part is taken care by the retrieval augmented generation. Okay. So I'll just pause here, like, to see if there are any questions. No questions? Okay. So I believe everyone is getting it. Okay. I'll skip this part. Okay. On this. Okay. I'll skip this part also. So, okay. Uh, so in terms of instructor personality, there can be mm, a lot of different personalities, but these are the four that we have identified. Okay. And these four personalities are actually inspired from the Big Five framework. Big Five is nothing but like it's a framework which defines the personality of a person in the form of these five dimensions: extraversion, conscientiousness, neuroticism, openness, and agreeableness. Now, what we really found is that these are probably some of the most common instructor personality types. And when we talk about, okay, these four personality types, when we really project them into the Big Five, okay, as per the Big Five uh, nomenclature, if we really project, okay, these four personality types, then you will see that it will have, like, creative nurturer would have will be high on extraversion, high on conscientiousness, high on openness, and high on agreeableness, and only low on neuroticism. Okay. So like you will see, like in all these, we have like instructors which have like personalities which are low on neuroticism. Okay. Whereas all, whereas the remaining three, there is only the variation in the openness and agreeableness, right? So, okay, now we have these four personality types. Okay. Uh, then how do you really do the fine tuning of the model? Now, fine tuning requires a lot of data. Okay. And where will you get that data from? Anyone? Any guesses? Where will you get that data from?
Yeah,
Where-
maybe somebody's recordings or some lectures, something like that.
or user inputs.
Mhm. I saw there were some people trying to join. Have they already joined? I'll assume that they have joined. Okay. Yeah. So see, one is like you do it completely manually. Okay. That you have like, okay, this is the question. Okay. And then this is the answer. Okay. In case the person is going to be like a creative nature, then this is the question. Okay. And then this is how a rigid instructor would really respond. So you can have those question answer pairs for each of those personality types, right? But how many question answer pairs that do you require? It seems like you require thousands of those. That's where all the problem starts, because when you say thousands of such question answer pairs is what you really need, then it becomes a problem related to time as well, because nobody lives that old in today's era. And uh, yeah, means then what do you do? What's the alternative? The other alternative is like use a very sophisticated language model, which really understands this big five framework, and then ask it to generate question answer pairs. And then you use those question answer pairs generated by a large language model to fine tune a smaller model. And that's what they have done in this work. What they have done is,
So this idea is same as key augmented retrieval, right?
no, this is not keyword
I mean,
augmented retrieval.
on the same line, like somewhat.
No, not even on the same lines. We are fine tuning the model. Okay, so we are generating the. So right now, what I am trying to explain is we are fine tuning, and in fine tuning, we are updating the model itself. In keyword augmented retrieval, CAR or RAG, we were not updating the LLM itself.
Yeah, but
We were just,
yeah, I'm sorry. Like what I mean is that we are doing the actual complex work little bit beforehand, right? Got it.
okay. So now one way of generating that synthetic data is you use a large language model, okay, which has the understanding of this big five personality characteristics. And if you have to get that information, get those question answer pairs from an LLM, then you need to again prompt it, right? There is no other way. You will have to prompt it, then only it will give you those type of question answer pairs, which
So,
are going to
Prabhuji,
serve as your training data set.
Hare Krishna Prabhu. So, is
Right,
it something,
right.
if you try to understand, is it something like we use one model to fit the other model and fine tune? So, for example, the real time example is that DeepSeek users used maybe Meta's Llama or
Yeah,
something,
you can
and
think
then,
like that. Yeah,
right? And then
yeah,
they,
that's a good way of thinking about it. Right.
so they fine tune their uh, DeepSeek model using the Llama,
Yeah,
right?
I mean, I would say yeah, that's a good way of thinking about it. I will not say that that's the actual way in which they did it,
Yeah. Mm-hmm.
but it's a good proxy.
Mm-hmm.
Okay, just give me 1 minute, okay? I have to change my location. Just give me 1 minute. Okay. Yeah, I'm back. So what I was saying is, uh, we generate data using a more sophisticated large language model, and that data has to be in the form of question answer pairs. Once we do that, use those question answer pairs to fine tune a model, fine tune another model, which would not probably have those capabilities, okay, of giving that type of personalized answers. And I think one of you said, okay, like, that is this the way that DeepSeek was actually trained? So I said that that's a good way of thinking about it, but it's not exactly the same. Okay. What they used is known as reinforcement learning using human feedback. That's a different framework altogether, which uses reinforcement learning. But here we are talking about fine tuning. Okay. Reinforcement learning also updates the model, just like fine tuning, but it does it in a different way. Okay. So we'll write again like a prompt, and we will tell a large language model to really create those question answer pairs. Okay. And once we have those question answer pairs, we are going to use it to fine tune a smaller language model like, say, Llama 3.1. Okay. So 3.1 has got 70 billion parameters, whereas the large language models have trillions of parameters. Now, what we want is, we want a smaller model to also have similar sort of characteristics in terms of generating the response along for those four different personalities. Okay. So uh, I covered this, okay, like synthetic data generation. Okay. Uh, it but so one way is like you generate your synthetic data set. But for Big Five, we also have one Big Five chat dialogues database, which is available in open source. In fact, to conduct this piece of fine tuning, we have reached out to the creators of Big Five chat dataset to give us their data, uh, and then fine tune the large language model, like fine tune the Llama 3.170B model. So, but in reality, the way they generated was also synthetic only. So now you have those question answer pairs, okay, where you have the question, okay, and then your the answer, okay, and you also specify that, okay, like this question answer pair belongs to this personality type. Okay. Now, the way this fine tuning approach really works is, you put a model, expose it to all this data. But when I say all this data, I would be careful. Okay. So first, you may feed all the data related to say the personality number one. Okay. And then you tell it, okay, that this is actually related to personality one. And for personality one, say, which was, I think, motivator. Okay. There would be set of question answer pairs, and that will be fed to the model. And model is supposed to now generate the answers which would really mimic the way answers are coming out from the existing language model. Okay. So any doubts still here? No doubts? Anyone wants to raise their hand and ask the question? Okay. So I assume that there are no questions. Okay. So Okay, let's not get into how the fine tuning really works. Okay, let's go step by step. So what is it that this fine tuning requires? One thing is very clear: you need the data set. Okay, in this case, we got the big five chat data set. Okay, then the next thing is that you need is a lot of compute power. I'll just give you some approximate idea. So a model which has 70 billion parameters during its training, it requires double the storage and RAM during the training itself. So, and if you have to do that, you have to store the entire model in a GPU chipset, okay, which is going to cost you fortune of money. So you can't really keep, so you can't really rely, okay, on any like sort of regular PCs, okay, when it comes to fine tuning. You really need GPUs, okay, which would have enough storage and processing capability to uh, use all the information, say, related to one personality in one go, and and then learn from it. So, any questions till now? Okay. So, uh, so where were we? Like we were talking about that you need a lot of GPU resources because 70 billion parameter model itself requires a lot of RAM to be stored. And yeah, when we are talking about 70 billion parameter models, it will like, yeah, means uh, like I think to fine tune one uh, 70 billion parameter model, you require two A100s. Okay, and that's very costly. Like those A100s are very costly. So that is, so two things we require: data set, then compute resources. Okay, or GPU resource. Then comes the third thing. Now, if the model is so large, and if the model will try, like if you are trying to uh, fine tune the model with all the data set, okay, and when we say fine tune, like we are updating the parameters of the model itself, right? So if you try to update all the parameters of all the models that we have already installed working properly, what you're risking is you are risking the model existing model to sort of learn things, okay, during the fine tuning in a way where it may learn things from the fine tuning data, but it may forget things, okay, which are already existing in the training data. So, and like people have observed, okay, that while doing full fine tuning, it has so happened that LLM started learning about seen, okay, in past. You talk, but with the latest information, they are able to recall. But with the older information, they've forgotten that information and they're not able to reply. So, any questions or concerns still here?
Prabhuji, so one thing still not clear for me is
Mm-hmm.
so how the fine tuning. So if we are using GPT, are we actually changing GPT with this fine tuning? Is that what is happening?
We are changing. During fine tuning, you do change or update the parameters of the model.
Okay. And but to do that, we are using the big five data set. Uh, eh, so that there is the data set. So
Mm-hmm.
how are the how are the parameters getting updated? Yes, I mean, how are we figuring out the new ones? We are also we are also using that big five data set to,
So can
I
you
guess
repeat your
that's
question once again? I did not clearly get your question.
yeah. So the question is how are we, what information are we using to update the model?
Question answer pairs.
Okay.
Okay. So suppose you ask the question, okay. Same question you ask the model and you write five different instructions. Every time for every different instruction type, it will generate the response in a different way.
Yeah.
For example, you might have written that, okay, like, yeah, means Wednesday onwards, okay, uh, you want to say teach in a way that, or speak or converse with the students in a way that you appear friendly.
Mm.
Then you would have question answer pairs, okay. There will be a question and then there will be an answer where the answer would be, say, written by someone, okay, such that it may sound friendly. And then you use that, okay, as a training data or fine tuning data to update the parameters of the model of your like the medium like in this case like llama 3.170b. So did I answer your question?
Oh, yeah, partly. I mean, so
Yeah, it's
the model we're
slightly
talking
different.
about is the actual model itself, or there is something in between?
No,
Like, I
actual
mean,
model
so if
itself.
we, okay, so then it
Okay,
changes for everybody?
it will, so see, like if you do full fine tuning, it will change the parameters, all the parameters of the model.
Hmm.
So if you do full fine tuning, yeah, it will empty your, like it's like emptying your uh sort of it's like updating all the parameters, okay, which are there.
Yeah.
Okay. So full fine tuning is very, very time consuming and resource intensive. That's where another technique, okay, which I want to cover today, LoRa, okay, or low
Yeah.
rank adaptation, does a much better job. The number of required parameters goes down by, like when you do LoRa, okay, compared to full fine tuning, you will see that the RAM requirement, okay, and everything, okay, like it will go down by say 80%.
Hmm.
So did I answer a question, Prabhuji?
Yeah, sure, Babuji. Yeah, thank you.
Yeah. See, like some of these things will become much more clear when you will really do the fine tuning, write the piece of code. Okay. That okay,
Y-
how does it really work? So those are sort of very sort of transactional things, okay. But I think what you need to better understand is okay, uh okay, so uh in case of LoRa, okay, which is also known as parameter efficient fine tuning, because parameter efficient because we are not really updating all the parameters or like all the weights of the existing language model. We are only changing a few of them. And when you talk, like sort of talk about like what do we really mean by few of them, that's what becomes clear here, okay, in this table. Okay. So here what we have shown is as we are really changing the LoRa rank, what is happening is the percentage of trainable parameters changing. But if you look at these absolute values of these percentages, pretty low, right? Close to 0%.
Your voice is coming in and out, Prabhu.
Sorry.
Yeah, we couldn't
So,
hear you for a few minutes in between.
I just took a pause, okay, so that all
Okay, I
of you
see.
can take a
Okay,
look
yeah,
at
right.
this table.
Yeah.
Like for LoRa, okay, there are other parameter, hyperparameters also, like dropout rate, learning rate, okay. Uh, but what is important is like, okay, like based on the LoRa rank, as you increase the LoRa rank, the percentage of trainable parameters also goes up. And if LoRa rank is sort of trending towards infinite, okay, then LoRa is same as full fine tuning, because in that case you will end up like the trainable parameters would be 100%. And like uh okay. Um so as you can see, like here in case of LoRa, we are changing very small percentage. Not even 1% of the trainable parameters are getting influenced. And when you really think about the compute requirements now with LoRa, they tremendously go down. So that is what they showed in this LoRa paper, that full fine tuning is possible, okay. And you really don't need full fine tuning. In that full fine tuning, there are chances that uh, the like uh, you, that you may sort of make the model forget things which are already there. Okay, override things which are already there in its memory. So those are some of the perils. Okay, uh, of say full fine tuning. Okay, any questions till here? Why are we not doing full fine tuning? Why are we doing LoRa? Anyone would like to try answering to this? Why do we
Yeah,
not do full fine tuning and do resort to LoRa?
yeah, mainly to do it efficiently to reduce the resource usage.
Exactly. So see, like full fine tuning, okay, like if you do it in a nice way so that it does not forget, full fine tuning does a very good job. Okay, very uh, but if say you have lot of data, okay, lot of text corpus. So now if you have lot of text corpus, of course, like you would have a lot of question answer pairs coming out of it. And lot of question answer pairs means lot of training data, means lot of storage, okay, training storage that is required. But in case of LoRa, like all those things become like less than 1 or 2%.
Prabhuji, so another thing, another question is so fine tuning is it actually teaching new things, or it is trying to enhance something that the model already knows? Because when you said, you know, making it forget some older things, which means like your new training is somehow making it unlearn, you know, either because you're amplifying what you're trying to teach it new, like, right? I mean, right? I mean, now everybody is talking about AI, so somehow everybody thinks AI is the only thing there, right? Because you're just like amplifying, is the hype. Is that partially what is happening with the fine tuning? Like you're feeding it so much new information about, like, okay, this is the only relevant thing.
So, see, like when we talk about LoRa, okay, like so consider a case, okay, where you are doing LoRa and where you're doing full fine tuning. Now, in case of both, okay, your data set may remain the same sort of question answer pairs. What really differs, okay, in case of LoRa is it does not know. Sorry, in case of LoRa, what it does is it will not like uh, update all the parameters of the language model. It will only update a few of them, maybe less than 1% or even less. So, in terms of like companies, okay, like if uh okay, let me rephrase, okay. So what I was saying is your training data set may remain the same, okay, in case of full fine tuning and LoRa. The thing that varies is in case of LoRa, you will change only very few parameters which really matter. In case of, whereas in case of full fine tuning, you'll update all the parameters and all the weights. And because you are doing that, you'll have to store a copy of the old weights along with the new ones. Okay, did I answer a question, Prabhuji?
Yeah, sure. Yes, Prabhuji.
Data set remains the same, okay, but uh, whether all the parameters are getting updated or not is what changes, okay, in case of fine tuning and full fine tuning. And like uh, I like the way I think about this is like uh, full fine tuning is nothing but like LoRa based fine tuning is like a more generalized, okay, approach, because when you really increase the rank, okay, and take it towards infinity or like order of 100, okay, or 1,000, that LoRa, like the number of training parameters will go up, and this would be as good as full fine tuning. Like your LoRa would become then as good as your full fine tuning.
Yes, Prabhu, understood. Thank you.
Okay, okay.
One question,
So
bro.
one,
Yeah, yeah.
So when we will decide to do just a fine tuning with LoRa versus full, like for example, you have raised the question like about Modi. Might be
Mm.
possible Modi is already in the existing fully trained model. So why I need, like, how to figure out, like, I need a fine tuning, like is there some news got, let's say, some new thing happened in the world, and that information is missing in the model, so that's the reason we want to feed to the model. Like, what is the triggering point? Like a new information, that's a triggering point to do a fine tuning. Like, what is the need? Like, because that information is missing and we are feeding new information, is that the understanding?
Can you repeat the last part of your question, please?
It's very, I'm just taking one step back, Prabhu. So just to understand when to do fine tuning, because model also knows mm, whatever we have trained for. But when we are, why we are doing the fine tuning? Because the information is missing in the model. That's the reason. I cannot hear you, bro.
No, I just took a pause. Okay, like it
Oh,
was
okay.
intentional. Okay. So, uh, okay, let me get to some metrics. Okay. Now, okay, you are doing fine tuning. You may be doing full fine tuning, or you may be doing LoRa. Okay, where you're not updating all the parameters. You may be doing any of these things, or you may be doing RAG. Okay, where you are sort of, yeah, putting all the information, okay, in the form of a vector database, and then letting LLM generate response. How would you measure, okay, whether RAG is doing a better job, or fine tuning is doing a better job, or like full fine tuning is doing a better job? So that is where evaluation metrics become important. Okay, and again, these evaluation metrics will also depend on the context, because when they, like, I don't know, like, that if you need to use all of these metrics, okay, together, or you need to use optimize one of these metrics. Again, see, like, it is all going to depend on your particular use case. Okay, so you would like to optimize or improve all the metrics or some of them. Okay, uh okay, so that's where you have to apply your judgment. But uh like, these are some of the standard ones, okay, like, which people try to look at, okay, when they're looking at responses generated by LLMs. Then there's another framework, okay, like, which known as ham framework, which is from Stanford. Okay, the full form of this is holistic evaluation of language models. So it has sort of, yeah, like, different attributes like accuracy, calibration, robustness, fairness, bias, toxicity. So they say they profile, like, means this, like, you can look at the responses generated by LLM, and like sort of apply, okay, your knowledge of, like, uh sorry, like, you sort of apply and calculate uh the values of these metrics, okay, and then see, like, okay, like, how are these metrics really changing? Are they going up, or are they going down? Okay. Uh, Going to the next slide. Okay. Uh, I did very briefly touch upon that you would require, say, two A100s, okay, if you want to fine tune a 70 billion parameter model like Llama 3.1. But what about just plain storage? Okay. So that's where, like, some of these calculations will give you some idea. So one parameter is actually 4 bytes. Okay, and 4 byte is like 4 byte also in 32-bit nomenclature. So one parameter is 4 bytes. 1 billion parameters would be like 4 GB. So ideally, yeah, like, when you multiply these two numbers, they look really big. Okay, like that. I think, but then comes the next part. Okay, that, okay, like, 1 billion parameters 4 GB. But while you're doing the fine tuning, there are other things are also that really need to retain their states. So that's where, like, this atom-based optimizer, okay, and the parameters, okay, in that come into the picture, and you have to account for those as well. And then finally, the other thing that comes in is like the activation. You'll have to, you can see, like, I have added +8, +4, +8, okay. So to really reach, okay, that place, okay, where people would really say book tickets, okay, for gradients, okay, or for, say, tutorial, sorry, uh, total, okay. So you have to add all those things and then arrive at okay that okay this is going to be the memory usage to store all the parameters corresponding to the language model that you are fine tuning. So if you'll do all these calculations, you will see that yeah, like A100 which has got 80 GB RAM, you would need two A100s, which means 160 GB RAM to take care of fine tuning this. So all these things are like yeah, very very compute and storage intensive. Sorry, is there a question?
No, it's clear, Prabhu.
Okay. So now one way to really reduce the requirement of storage is quantization. So in quantization, what we really do is we sort of convert a 32-bit float number into a 16-bit or a 4-bit. So uh, you'll see that with quantization, the performance of the model changes a little bit, not that much, but you are able to achieve that objective. Okay, that some primary objective that okay that yeah maybe like you did not select the right person. So I'll stop here, okay, like because we started with a brief overview of RAG, okay, then we talk about fine tuning, okay, and where we want to really apply fine tuning versus RAG. Then we looked at okay, like when we are really doing fine tuning, what are some of the considerations or metrics, okay, that one needs to keep in mind. And then we also looked at okay, like uh,
Okay, Prabhuji, thank you so much.
okay,
It's
okay,
pretty late
thank
for
you
you.
everyone. Yeah,
Yeah, thank you, Prabhu.
yeah.
Thanks for staying up so late.
So next week I may be flying, okay, back to US. So there won't be any class next week. In case this India-Pakistan conflict flares up again and like flights are impacted and I have to say stay back here in India, then there will be a class, but I will accordingly keep all of you posted.
Okay, sure, Prabhu. Yeah,
Yeah.
we could choose a different time that's a bit more convenient for you. I know it's quite late.
Uh,
So
the challenge is
yeah.
like, yeah, means I would like to do it earlier, much earlier, say
Hmm.
9 p.m. or say 10 p.m. my time, but my kids are like both of my kids are like broadly awake. Okay, so it's very difficult to take a class at that time.
Yeah.
Yeah.
Or
So
your
if
morning
I'm
time also may work. You know, it will be evening for us, but
yeah, morning would work. Yeah, would be
yeah.
more like yeah, much more doable.
Yeah. So Saturday evening for us will be Sunday morning for you. So we can try
Yeah,
that.
yeah.
Yeah.
So yeah,
Yeah, that could be an alternative. Yeah.
okay. Thank you.
Thank
All
you,
right.
Prabhuji.
Thanks.
Thank you,
Prabhu.
Prabhu.
Yeah,
Hare Krishna.
Hare Krishna,
thank
Prabhu.
you everyone. Hare
Hare
Krishna.
Krishna.
Thank you.
Thank you.
Thank you, bro. Hare
Thank
Krishna.
you, Hare Krishna.